welcome everyone to the GitLab Virtual Connect Day. Thanks for joining us today from all over Europe. We are very excited to have you on. My name is Lisa and I will be your host for today's session. In this webcast, we will be covering topics such as continuous integration and delivery, an exciting insight into Polaris, and last but not least, version control and collaboration in DevOps. Before we get started, I'm going to cover a couple of housekeeping items. First, feel free to ask questions throughout the presentation. You can use the Q&A function at the bottom of your screen for that. Your question will be answered directly in the chat by our experts working behind the scenes. We'll have dedicated time for a live Q&A at the end of the webcast, where we will pick from the questions posted in the chat during the webcast. And lastly, I want to inform you that we will recording today's presentation. Just everyone in attendance is aware. You will all receive the presentations in our follow-up email. Also, there will be a quick feedback survey with a chance on a great prize. I would like to introduce you to a gimmick we are implementing into this webcast. In our studio, we have Daniel Stieglitz, who is a professional graphic recorder. He will scribble his notes into some nice graphics and will show these during the show. This will help us all visualize the topics and will be shared after the event. Today, we will have 3 speakers, and here you can see the graphic interpretation of them. Firstly, Christoph Goossens on the left side will give an overview on CI/CD and how important this is. Secondly, Jordi, you can see him on the right side, Mon Companies will interview Red Baumgar in the middle about the Polaris project, autonomous spacecraft operations. And thirdly, Jordi will come back and present about version control and collaboration in DevOps. Lastly, we'll have a live Q&A session to close this show and have all your questions answered. So now I am happy to introduce our first speaker. He is a solution architect at GitLab from Belgium and really excited to give you a comprehensive overview of continuous integration and continuous delivery, focusing on the business impacts of poor CI/CD. Please give a warm virtual applause for Christoph Goossens.
Hi, and welcome to GitLab Connect. My name is Christoph Goossens, and I'll be your designated presenter, meaning you're stuck with me in the next half an hour or so get comfortable. In this section, I'll be covering the basics by explaining what CI/CD is. We are all talking about the same thing, why CI/CD is useful and why it should matter to you, how GitLab CI/CD can help you on this journey. But unfortunately, we don't have sufficient time to cover all the features, but I'll be highlighting a couple of them to give you an idea of what is possible. So let's get started. CI stands for continuous integration, and CD is a bit more tricky since it can both mean continuous delivery as well as continuous deployment. Let's get started with continuous integration first. Martin Fowler, a well-known thought leader in terms of software architecture, gave this definition to continuous integration already back in 2006. It comes down to each team member integrating their work on at least a daily basis, so you'll get multiple integrations per day. These integrations are then automatically verified and tested as part of the build process, so you can detect errors as quickly as possible, and this leads to less integration problems and allows a team to develop software faster with increased consistency. In order to implement effective CI, we should implement a couple of key practices. First of all, we should maintain a single source repository. In essence, meaning we need a source code management system like GitLab. Secondly, the build should always be automated, not only locally on the developer's machine, but rather running on a build server. Next, everybody commits to the mainline on every day. The mainline here being the piece of software that you and your team are working on. And depending on your branching strategy, this could be a feature branch, a master branch, or trunk. And by doing this, you're communicating to the other developers what changes you have done. And by doing this often, people know quickly if adjustments are needed. As with other practices outside of development, your pipeline is your lifeline. If your pipeline fails, this should be fixed as soon as possible. If it's neglected, your current work that is done on top of these changes won't work either as long as the problem is being fixed. Next, the speed of builds are very important because they will provide you fast feedback. And if not, they have the possibility to slow down the entire process. Tests should also be run in the most realistic environment as possible. So, meaning an environment that is as close to the production environment as possible, or at least, or in best case scenario, a clone of the production environment. Transparency is very important, and everybody should be able to see what's going on and what the latest status is of all the different assets, all the different work. Dashboards can help out in this. And finally, to have a realistic approach to continuous integration, you'll need to deploy towards multiple environments multiple times before eventually deploying to production. Basically, repeating the same process over and over. So this should be an automated process, and that's why we're saying that you should automate your deployment. To summarize, each developer should at least commit once a day to the shared mainline. This will trigger an automated build and test process that, if a failure occurs, needs to be repaired as soon as possible. Continue with continuous delivery and continuous deployment. In 2013, Martin Fowler extended his definition to include continuous delivery and continuous deployment. He explains that with continuous delivery, it should be possible to organize the development process in such a way that you are capable of releasing to production at any given time. On top of that, continuous deployment goes even further and deploys every change that has gone through the pipeline automatically into production. In essence, resulting in many different deployments to production on a daily basis. Of course, that might not be possible for all types of projects. And you can decide to set up, for instance, continuous deployments only for non-production environments like testing environments, etc., but and only use continuous delivery for production environment. But in any case, in order to get to this stage, you'll need to have an adapted workflow that supports this. So to summarize, you're doing continuous delivery when you have the capability to deploy on demand at any given time. When you're making the deployability of your application a priority, you are able to get quick feedback from assets like build results, quality metrics, test results at any given time. And you're able to deploy any version of your application to any environment with a push of a button. A mouse click is okay as well. On the other hand, you're doing continuous deployment when you have automated all the possible parts of the delivery process. You have established a close collaboration between all stakeholders. So why should you implement CI/CD? Let's start with CI first. I'm pretty sure that most of you have already some form of CI setup, but for the sake of completeness, let's remind ourselves what the benefits are. First of all, we can detect errors as quickly as possible. So we can fix those problems when they're still fresh in our minds. I don't know about you, but when I need to fix a problem that are in a code that I've written like a month ago, I tend to take a bit more time than I wrote it only yesterday. Next, we can reduce integration problems because smaller problems are easier to digest. And by avoiding compounding problems, it allows teams to develop faster with more confidence. Now, some benefits of continuous delivery and deployments. The first thing that we can do is we can ensure that every change is releasable. By testing everything, including our deployment, before calling it done, we're sure that every change is releasable. We can lower the risk of each release, basically making releases more boring because we're losing the anxiety because we're used to it more. And we deliver more value frequently. because we have the reliable deployments, we can do more releases, which also enables a tighter customer feedback loop because fast and frequent customer feedback on changes, the, we're, we're enabling to deliver more value faster to the customer, which each release. So what about business impact? How can CI/CD have an impact on your business? Well, studies have shown that successfully applying continuous delivery together with lean management results into an improvement of an organization's culture drive. This, in turn, leads to a better job satisfaction, which is very important for our prime resource of every company being our employees. It means that our employees will be able to identify themselves better and gear themselves towards their own goals and align their own goals with the goals with the company and with the identity of the company. Because everybody is aligned and working the same on the same problem, the deployment pains will go down as well, and there will be lesser unplanned work, which in turn will reduces the team burnout, which in turn will lead to better software delivery performance and organizational performance, including non-commercial performance like effectiveness, efficiency, and customer satisfaction. So why GitLab CI/CD? For the emojis, of course. Of course, on a more serious note, GitLab started out as a source code management system back in 2011, and then quickly added CI/CD capabilities based on the best practices, allowing enterprises to adopt these more quickly. Let's go over a couple of advantages of GitLab CI. First of all, GitLab CI is completely integrated so you can manage the entire lifecycle of your application from within the same application. GitLab is open source, and this counts for both community and enterprise editions. GitLab CI is easy to learn, so you can get started quickly, and it's seamlessly integrated in the rest of GitLab, resulting in a better user experience. For example, you can see the status of your CI at all times and in the each job can be run separate from each other and in parallel on different machines, allowing the pipeline to progress faster. And as a result of that, you get faster feedback. GitLab CI is optimized to support multiple delivery models. Pipelines can be written in multiple phases, which can include steps that need to be manually executed if that's necessary. It's possible to manage multiple environments for the same project, having multiple environment variables, and much more. Last but not least, GitLab CI is scalable, and let's continue a bit on this and on why we are calling it scalable on the next slide. So when we say GitLab CI scalable, this is why, or rather how we do it. The CI jobs are written in one or more scripts stored together on the project source on the GitLab server together with the project source code. The jobs are executed by workers called GitLab runners that are installed on other machines or servers, which can be bare metal machines, virtual machines, Docker, or Kubernetes clusters. Each project can have multiple runners serving a specific purpose or just to divide the workload. And in the same way, a pool of runners can be shared by multiple projects as well. Or any combination of the different examples that were given up to now, which make this a very powerful and flexible system to support all of your CI/CD needs. Now, let's highlight a couple of CI/CD features from GitLab. GitLab has a lot of CI-related capabilities, not to mention other capabilities like a link to security, monitoring, serverless, and more. And I'll highlight a couple of them today, and you see a couple of them on these slides already. So one of the interesting things with GitLab CI is the ability to execute jobs on other machines besides the GitLab server. You have the possibility to distribute the jobs over multiple machines to speed up the execution time, but at the same time, you can also dedicate certain tasks to specific runners. Next to that, our pipelines are very flexible, allowing you to run your jobs in parallel, sequentially, or dependent on the completion of another job. If you're using Kubernetes to install your runners on, it's really easy to make them auto-scale to support the current workload. And the built-in Docker support allows you to use specific Docker images for each of the jobs. For example, images that have specialized tools pre-installed for that specific job to function. Let's take an example. Here, in this example, you can see three runners that are configured. Two of them are running as part of a Kubernetes cluster, and one is running as a virtual machine. As you can see, you have the ability to provide tags for each of these runners. These tags I can use when writing my CI script to select the runner type that I need for each job. For example, on the left, you can see that in the testing phase, there are two jobs running in parallel, one on the Kubernetes cluster and the other on a virtual machine. The two other jobs will be run after that in sequential order. And on a side note, I wasn't lying about emojis. In the same way, we can define what image each job needs to use. In this example, the first one is one that is used to construct the Docker images. The second one is used to deploy them to the Kubernetes cluster. As mentioned before, feedback is very important. And in this example, you can see a complete pipeline that will run the code quality scan, execute a unit test, build a container, deploy an application that is containerized, and launch the performance test on the deployed application. The developer can follow each step of this process from within the same view in GitLab, and at the same time, all results are being reported back to a central location, being the merge request. Merge request is GitLab's functionality that allows the developer to define and work on new changes that will get integrated back into the application's mainline whenever necessary, whenever ready. And this is an example of such a merge request, or at least the part of it that shows at the top right a minimized version of the pipeline, so you know what the status of the pipeline is. The results of the code quality scan in the middle, followed by the results of the performance test, of the stress test, and at the bottom, the results of the unit test. Of course, this completely depends of what is defined in your pipeline. So in other situations, all results can be shown here as well, like the result of the security test, etc. Look at the log files of the running jobs. This can be done in real time from within GitLab's interface. That's what you're seeing here as well. And last but not least, all members have access to the environment dashboard, showing all the currently deployed applications per environment and providing direct links to the monitoring metrics. And they can even, with the appropriate permissions, of course, open a direct SSH connection to these environments and interact with it. So up to now, we've highlighted a couple of nice features. However, to help you go even faster, GitLab has implemented a feature called Auto DevOps. Auto DevOps automatically is going to detect what technology is being used based on the files available in your repository. After detecting which the technology is being used, it will automatically generate the rest of the pipeline going to build your application, and then it's going to verify the application, including the security of your application, security of the source code, dependencies that are being used, the containers that are being used, the license compliance, whether the license compliance is okay, and some dynamic application security scans. It's going to package your application and deploy it as a review application. So you have a running application, all completely automated, so you can start working and validating whether your application does what it's meaning to do. All the underlying infrastructure is automatically configured and monitored. So whenever you run the performance test in one of the last steps, you can follow up on the performance of your application itself. These 12 features not only work seamlessly together, but work together automatically with almost no configuration whatsoever. We think that's the best way to bring these best practices to everyone involved in delivering software. And now let's see it in action. And off we go. I've opened GitLab on the events group that I already prepared before, together with one project, as you can see, the only project that is currently available over here. But to show you how easy it is to set up Auto DevOps or to get started with Auto DevOps, I have prepared a Node.js uh, folder already, which, as you can see here, does not contain any GitLab CI definition whatsoever. Normally, you should see here a .gitlab CI YAML file where we're going to define everything in it, but it's not there. It's even not yet a Git repository. So let's make it a Git repository, add the files and commit those files to the server. Uh, and of course, at last one, we need to push those files to the server and choose a new name for our project. There you go. So GL Connect it is. Then it will automatically set up a new project for us, upload all the changes to the Git repository, and show us the URL of our newly created project. So when we open that, we can see that all the different changes, well, all the files have been committed and pushed to the server. And we see that there's already a pipeline running. This is running because Auto DevOps is currently enabled. You can validate it here with settings CI/CD, and there you have an option Auto DevOps over here. Now for us, it's enabled on the instance level, so on the highest level, but you can choose to override this if you want and decide what deployment strategy you want. So by default on our instance, it's set to continuous deployment to production, meaning every change that we're merging back into master is going to be deployed all the way into production. However, you have the other alternative options to push it into productions, but using a timed incremental rollout. So it's only going to be one portion at a time, or automatically deploy to staging, and afterwards have a manual action to deploy back to production. So I'll go out of this here. And if we're going to see within our pipeline, we can see that, well, the build step has already completed. And in the meantime, all the other testing steps have been launched. And in these tests, you see that in these steps, you see that the test is the next step. Then it's going to deploy a review application, run some the dynamic security scans on that review application, and then deploy it into production. Next step is last step is the performance test, and then a cleanup of this dust environment so it doesn't keep on running all the time. Now this is the pipeline for specifically for the master, so running into production. But let's see how it shows up when we're actually developing something. So let's create a new issue. Uh, let's call it Virtual Connect. There's a lot of things that you can do here, but it's not the scope of today's demo. So I'll skip all of this and create a merge request, because an issue is the problem statement or the whatever we want to get fixed or get implemented. And when a merge request will resolve this, we're going to work to resolve this issue. So automatically it's linked to that issue, of course, and we have created our proper feature branch automatically as well. Now, as a developer, of course, you can use your own IDE, but for the sake of the demo, I'll just open the code in the web IDE, which is also very useful if you have a very large repository and you don't want to pull in all the well, the entire repository to your local machine just to do one single change. Now let's see. We need to go in the index file and change the message here. Well, or at least do all the changes that we want. Of course, we need to update our tests because otherwise it's going to fail and the validation. And we can change some colors here. Background color is orange red. There you go. And this color will change from blue to white. Of course, this is not necessary. There you go. Notice that he automatically updates the colors here as well. Then we can commit back to it. And we have the option to commit directly to the newly created branch, or we can create a new branch if we decide that it's not entirely the right way to do it. But for now, I'll just commit to this feature branch that we just created. At the bottom, we see that he already launched a pipeline for this merge request as well. And on the right side here, we can see also the different steps that our pipeline is going to run, meaning we can keep track on what is running and continue working at the same time as well. Now let's see what he is doing. So we have launched a pipeline here, and it's a very similar pipeline as the one that we saw before for master. However, we're not going to well deploy into production since this is a feature branch, and that will only happen whenever all the approvals are given, whenever everything is ready to merge it back into the master. Only then we're going to merge it back according to our deployment strategy that we have chosen. All right. Now, as with all cooking shows, we have prepared something, and that's the project that we saw before. There you go. If I look at this project now, we already have run the entire pipeline for our master, and including for the merge requests itself as well. So we have changed something here. In this case, it was for the corporate branding, but it's very similar. And we have the entire overview of what happens in order for this merge to to be successful. So we can see all the different changes that were done, the pipelines that were run, and here you have the miniature version of that pipeline, so you can easily see that overall it was running fine. And if we drill down into it, we can even see the full status of it, including, if I click again, including the entire output log of the runner itself, of the job that was run on the runner itself. Then next to that, I still don't have a GitLab CI YAML file over here. However, if I noticed here that my pipeline is saying that it's blocked. So let's try to find out why it's blocked. And here you see that there's a slight difference in between my prepare project and the project that we just created. And that's these stages over here. So I have opted for this demonstration within the prepared project to enable the staging and the canary releases. What does that mean? Well, staging can be used just to get approval or to run some additional testing on it, or for whatever reason that you want. So it's basically running in between the feature branch and the production branch. So it's more pre-production environments. And for the canary releases, it's an actual production release. However, it is not. It is not running for all the different pods that are available into production. So small reminder, all of these are running in Kubernetes. And in Kubernetes, we have multiple pods. Let me switch to our environment screen or as an environment dashboard to make it more clear. So as you can see, our staging environment over here only has one pod running. However, our production environment has 5 instances running, so 5 pods that are running over there, and one of them is running in a Canary release, and that's highlighted here with the yellow circle, meaning that if I go into our production environment, I can do this by clicking here in the open live environment. I'll have our production environment, the current version of our production environment. And if I refresh a couple of times, there you go, I might end up in the Canary release, showing the newer version already. And the advantage of that is you can, if there's something wrong with it, you can have uh, initial indication that you probably need to roll it back. Or if everything is fine, you can decide to roll it out to production completely. Rolling out to production, you can do from either from here, production running out to production, or in the previous view with in the pipeline itself. You here also have the possibility to well, just click on play, and now it's going to be deploying the latest stage that was already running in Canary release into production as well. Now, focusing on CI/CD, I can hear a couple of you thinking and asking, yeah, that's all fine, but we have exceptions that this is only working for default applications that don't require any special treatment anymore. So let's quickly see how we can use Auto DevOps in general without actually using Auto DevOps in so one of the first things that you can decide to do is without creating a file completely from scratch, because now Auto DevOps is disabled. Yeah, okay, it's still running, but that was the previous pipeline run that is still going. How can we set it up without actually writing everything from scratch? So if I click on the Setup CI/CD button, which is now available since Auto DevOps is no longer enabled, here we're going to write our CI/CD file or GitLab CI YAML file. Of course, we can do this from scratch, or we can decide to use one of the predefined templates. So if I go to, for instance, for Node.js, it will automatically fill in the necessary steps for Node.js. Or if we like Auto DevOps, but we need to adapt a couple of things, we can choose the Auto DevOps template, which is basically going to show you all the different steps that are available. And depending of the settings, you will be able to tweak it more. Now, suppose that we want to adjust the build step slightly and add an additional stage, an additional job to it. Then we don't need to rewrite everything. We just can add on top of it. So if I just, for instance, copy paste another portion of it, there we go, which is only going to echo out the why hello here sign, and it's part of the build stage. This is basically going to be applied on top of the existing template that was there. By the way, notice that not all of the steps are defined here, but most of them are defined in these templates, and they are publicly available as well. If I open up one of these links, you can see the content of it, and as usual, it's open source, so you can submit merge requests to them, which can potentially get activated. Of course, it's also a nice way of getting an idea of what is possible with CI/CD from GitLab as well. So whenever I commit these changes, I'm adding the GitLab CI file. Now it's applied. So when I go back to my project and go to my running pipeline, you now see that we have added the hello stage over there, or job, I should say, over there. And like this, we can adapt the entire auto DevOps, or use auto DevOps as a basic template and work from there on. Of course, GitLab has plenty of more features, but we would need a lot more time to go through all of them. If you would like to know more, please reach out to your local GitLab team, and we will set up a dedicated session for you. This concludes my session on why CI/CD matters. Enjoy the rest of the program, and I hope to see you all in the near future, starting with the upcoming Q&A session. Thank you.
So thank you very much, Christoph, for this detailed information on CI/CD. I feel a little bit smarter now. I hope you do too. As mentioned before, all questions will be answered in the chat, and we'll host a live Q&A at the end of this webcast. Now let's see what our graphic recorder has created. Daniel, I can see at the top there's the topic, why CI/CD, and in the background we can see GitLab, which covers nearly everything. In the middle, there's the software illustrated as a robot. And at the bottom left, let's go there again, there is continuous integration, different people working on the same product or project, maybe at the same time. And on the bottom right, there's continuous delivery, the software that can be delivered or developed 24/7 to the customers. And GitLab can organize all of that with a lot of advantages on the business side, which is the left side, and on the customer side, which is the right side. Thanks for this awesome graphic, Daniel. And before we go over to the next session, I want to mention our quiz. Prior to this show, we sent out a quiz by email, which you've all received. Everybody who filled out the quiz form correctly is in our raffle to win the final prize, this amazing box of GitLab giveaways with socks and bags, stickers, t-shirt, quite a lot of stuff. And the winner will be announced at the end of today's session. After today's meeting, we will send out a feedback form by email. Please make sure to fill it out and send it back to us. For all those of you who fill it out, the feedback form, there's another surprise waiting. We have another great prize, so stay tuned. So now we are coming to our next session. Therefore, I want to welcome two experts on Polaris, open source machine learning for the future of autonomous spacecraft operations, a worldwide collaboration enabled by GitLab. From Canada to India to sculpt the future of space operations, may I have a warm welcome for Red Baumgar, core contributor at Libre Space Foundation, and Jordi Mon Company's senior product marketing manager at GitLab.
Hey, hello everyone.
Hello.
Hi Red, how are you doing?
I'm good. And you?
I'm fine. Bit hot here, but fine. So thanks, Lisa, for the introduction. Yes, in this second section of the GitLab Connect, we're gonna cover how Polaris, what the project Polaris is all about, and how it is part of the Libre Space Foundation, and how GitLab helps them achieve their goals as a distributed team, as an open source team, and many other challenges through their way. So one of the maintainers and contributors to that project is Red. Would you introduce yourself?
Yes, thank you, Jordi. Yes, so I contribute to this project. So this is a challenge actually I was facing when I was a data scientist at the European Space Agency. I had the chance to join the team with two other guys who started this project called Polaris, which aims at tackling a spacecraft operator workload by using machine learning, helping them to detect anomalies in their spacecraft. So
Right.
we've gone a bit far at this point, and I'm glad we can share that. Also, recently we joined the LibreSpace Foundation
Yeah.
as the project, and as my T-shirt
Yeah.
is stating.
tell us more. Tell us a little bit of what the LibreSpace Foundation is about and the goals, and how does Polaris fit in that? And then we'll jump onto Polaris.
All right. Yeah. So the LibreSpace Foundation is a foundation that aims at promoting, advancing, and developing Libre, meaning free and open source technologies and knowledge for space explorations, so that everybody, anyone in the world could actually benefit from it and play a role in that. So I put the link on the slide, which is on the manifesto, which shares actually our values and why we do that. I think you would appreciate that if you're into space and you're a dreamer like me. So please have a look. The main project of LibreSpace and how it was actually born is actually building ground stations. You see those three antennas, different antennas that you've seen. That is really big ones, but also smaller ones. Doesn't mean they're not good, but it's just smaller. And they are on roofs in the backyard. Anyone can do it. The blueprints are available. Everything is open source. So it's up to you to just take the time and get into this. And on the far right, you see a CubeSat. So LibreSpace is developing ground systems, ground stations, and also bringing this knowledge to actually building small satellites. Like you see here, this is what we call a CubeSat, a 2 unique CubeSat. I will maybe show a bit about that later.
Okay. So what about the Polaris project? How does that fit into the LibreSpace Foundation?
So the project with the antennas that you've seen is called SatNogs. It's about more than 1,000 stations all around the world, but you have up to 200, 250 always online. You can go to their website. I think it's below us somewhere in the slide. I'll share the slides.
Satnogs.org. Satnogs.org.
Yeah, exactly. Yeah, satnogs.org, and you can check the observations, meaning the data frames that we've got from the satellites, and it's live. You see things happening in live. It's scheduled, so you actually connect your ground station when you have one, and it turns or rotate as the photo shows. This antenna is on a rotator. So we use the data from that. Yeah, thank you. And we have the telemetry for about 400 spacecraft, and for now we focused on just few of them, just to get hands-on and creating Polaris with them. So and Polaris, the role of Polaris is I think on the next slide.
Yeah.
It's really like the two goals, like reducing the operator workload because you have so many telemetry per satellite. On big satellites like governmental satellites, you have 20 to 40,000 parameters. I mean, you can't handle that alone. That's why the teams are big.
Wow.
For small satellites, it's more like hundreds, 200 sensors. That's still a lot. And so we are trying to enable autonomous spacecraft operations by building knowledge on what we get from this data. So understanding the links between the sensors, the links between anomalies and what's happening in the context of the spacecraft and the mission.
So then the end goal is twofold, is you've got a set of users, which would be the operators, and the aim of the Polaris project is to make a ton of information usable for them, and at the same time try to automate as much as possible spacecraft, or what? Okay. Nice.
Well, the first, the operations. So we're trying to see if we can replan, if we get the plan. So we're not there yet, but that would be the goal. Yeah, that would be a nice goal. And actually, those 2 points I put, it's like the if you want to get hired at SpaceX, that's part of the job description.
So what about the amount of data? I mean, that's the actual challenge, right? I mean, the Polaris project and the end user of the Polaris project, or anyone working in this as an operator, is forced to make sense of a ton of data, right?
Yeah, that's true. Yeah, I think it's not really like it's big data. It's not really big data, but it's complex data.
Okay.
because of the interrelations you have. You have time series, you have hundreds of time series, and you need to make sense of it all. So, but just to understand what operations are, I just put like some kind of graphs here, where operations on the satellite starts when the satellites get released from the launcher. So you have the last stage that you see on the launcher here with an artistic view. That is ExoMars. It's an ESA mission. And then when the satellites release, then it has to be autonomous in connecting with the Earth. So you have radio links that are automatically connecting with the Earth. And on the next slides, you see this kind of handover between the people on the left managing the launcher and the people on the right managing operations. That's showing you the complexity of the thing. People on the right, that's a whole team for one spacecraft, those big scientific spacecraft. So, and the only link with the spacecraft is this radio link, but that's to understand spacecraft, that's the telemetry. So all those parameters and sensors they put and designed on ground. And so on every seat on the two front rows, you would see you would have one person per subsystem. So you have solar panels, you have a power system, you have the thermal subsystem, you have the radio system. It's a system itself.
Wow.
And then you have the mission managers and directors, flight controllers. So yeah,
this is what we see in the
complexity.
movies, right? This is what we see in the
Exactly,
movies
yeah.
When they celebrate, right? So
the
group
when
on
they
the
have
right,
like a long mission. Yeah.
the group on the right is the end user, right? Of the information that that the Polaris project is trying to make sense of.
Exactly.
And these guys and this people are not only consuming information, which is a lot. You said it's not big data, but it's a huge amount of data through the telemetry and so on. And they have to make very important decisions based on that data. So
yeah, true.
How have you decided to make them consume that data and understand it?
Yes, so they have their own. Here you have a picture of they have their own ground station networks. Although they have actually a SatNOG station on the operation center in Darmstadt, not far from Frankfurt. To manage a CubeSat mission like you see here. So CubeSat is a 10 by 10 by 10 centimeter cube. Usually you want to put payloads, meaning you want to put cameras, you want to put something you want to do in orbit, So it's you have to make it a bit bigger. So you take two units, like two cubes, one to another. That's the example of this CubeSat, the UP-SAT. And which was made and fully open source by the Libre Space Foundation, but
nice.
some pieces of hardware that we don't have the technology yet. Then you have other missions like the cubic missions, which is like a 5 by 5 by 5 centimeter satellite, so a pico cube somehow, very small. And on those ones, you have clusters, but yet so that's the users of all those. Of this data that the SatNOG network is getting. It's not really ESA per se or NASA. It's like people like universities making their own CubeSat missions all around the world. They actually, you have users of this.
Okay.
And so we use that too.
Okay, because I jumped into the visualization too early. We'll see that later.
Okay.
Because didn't we? Because the decisions these people, not only the people that we saw in the previous slide, sort of like the command control people and the operators, but also universities and so on that try to make sense. They have to incorporate all the types of data, right? Not only the one that comes from the payloads itself or the radio emissions, but rather other types of data.
Yeah. I think the engineers, explicitly or implicitly, they actually use everything they have in their context. So we're trying to make something autonomous. So we have to get this data automatically. So we are trying to use other pieces of data that are representing the space weather that we call the space weather. So what is coming from the sun, what kind of gamma rays you could have around, like coming maybe from deep space. We're trying to propagate the orbits of the satellites. So at each time step, we know where the satellite is in the orbit, which speed it has, etc. And in the telemetry, we have information like the orientation of the satellite, because it's a cube, so it's important to know which facing is facing the sun. So if you have a temperature problem, then you can actually relate to this information, and that will be machine learning doing that. So we have to gather all the data to make sense. We transform it to make sense, and that's what we do. But and since we do everything open source and libre, we have to make sure that the data sources can be used by everyone. So we have a blog post here that pushes for open data on certain areas.
Okay. So then, now is the part that I was mentioning before. So how do you make sense of all these sources of data that are huge or very different, vast in their magnitudes, and how do you present it to the end user?
Yeah. So we have chosen to go for a graph visualization, and at ESA, that's what I try to show, and it worked pretty well with the spectral operators. And so the thing is that with a graph, you have so many information. So we try not to overload. So you see only nodes, which are telemetry. And when you have a link, that means that you have a dependencies between telemetry. So here we're clicking on one of them, which is related to the attitude control system. So we can highlight nodes. So we have a search box that actually also used to search for nodes. So we're looking for gyrometers, which are linked to the attitude control at some point. So you see they're directly linked there. So that makes sense so far. So we highlighted them. We want to highlight the attitude determination control system that we do then. It's in green. And then let's say I have a problem with the battery and I want to link that to the battery. So and I want to see what could be the link to battery telemetry information. So here I have a node which is not too far, and also like proximity is important in the graph. So that's kind of interesting. If it's not too clear, you can pull things quite dynamic. So you see the link between the green and the blue, and that's this one, which I think is something related to power management. So which makes sense, you know, yeah, you need power to manage your attitude to move your spacecraft, and that drains power from the battery. So that's kind of a scenario of usage. But when you have a problem, you want to make links, and the graph have the links, and the search is faster if you didn't have that.
So I'm quite fascinated by, I mean, we've gone through the Polaris project in 10 minutes, 12 rather, which is ridiculous. We would need hours to explain it. But so far, like at the surface level, we can understand that this project is just huge in terms of data sources, of the number of them, of amount of data, even though you consider it's not big data, and so on. I mean, there's so many levels. Even the interface, like the decisions you've made to abstract all that information and present it to the end user, who's making like pretty complex decisions upon them. So first of all, congratulations so far. This is done by you and the rest of the team on
Thank you, Jordi.
a topic we will cover right now. And you're doing it on your free time, and it's incredible. So congratulations. And I can see a lot of challenges coming ahead, because this I don't know, for example, this interface can get more complex, right? I mean, what information goes in, what information goes out? How do you present it, right? For example, I think we talked previously about how did you decide to represent the intensity of the link, right?
Oh yeah, I didn't mention that, but if you zoom in the graph in the link, you would see some particles that goes with certain speed, and the faster they go, the stronger is the link. That's,
okay.
That's
there you go. I mean, it's an arbitrary decision to represent a complex set of data behind. So again, like I love it so far, and I really encourage everyone that is fascinated by space operations, space in general, cosmology, is it? I always confuse cosmology with the non-scientific version of it.
Astrophysics
and so on.
Astronomy.
Astrophysics, rather, yeah. To collaborate and jump on the project. All the links are there to give a hand. Because, hey, who's putting all this together? This is my next question. So tell us a little bit about the team and the tools that you're using, because it's just, again, you pulled it off, and it's not many of you, and you're quite distributed.
Yeah, that's true. So we actually the tools chain that we're using and trying to make them, using only open source things. So we're on Riot instead of Slack, for instance, which is based on the Matrix network, decentralized. We use GitLab. I mean, we would not live without GitLab. It's everything code, everything project, actually, I should have put. And we use Jitsi for video conferencing. This is very nice. And the hard thing is that, to find the right time, and we still manage because we have people in Canada, and but actually on the West Coast, not really in the East
Wow.
Coast of Canada. So and our student for the Google Summer of Code this year is in India. So we need
So from
to,
west coast of Canada to India, all the way in between
Vancouver,
France, Germany, Spain.
Yeah, exactly. So myself, I'm in Germany. We have two other contributors in Germany. One of them is also another maintainer. And then we have in Spain, we have Xabi, and in Canada, this is Hugo. Both of them actually had the idea of starting this project, and this is a cool thing. Yeah, and we
So how
have
does
very
the
different profiles.
Yeah. Oh, nice. So yeah, hybrid team. Yeah. Cross-functional team. So how does let us talk a little bit, how does the project look like in GitLab? Like, what is the rationale of the older structure, and how, let's then move on to how you actually push work forward and collaborate.
Yeah, so we didn't really like overthink that. We have main Polaris repository that you will see in this as a subfolder in this folder, in the Polaris folder. As being part of the LibreSpace Foundations brought some more structure to everything. So we have a Polaris organizational where we actually track issues only for the project initiatives, project events, or interactions with the LibreSpace Foundation. We have Betsy, which is an example of, we have something in Polaris which we could extract and make an external module. So we did that. So this is an external package. And then we have a playground, to avoid having big files in Polaris. This is a Python-based project. So we like to use Jupyter notebooks, but sometimes they are big files and we don't want to, clutter the main repository. So also it's a playground, so you feel free to do whatever.
Nice, yeah.
And then
branch out
I think two left. That is the Docker and test suites. Test suites more like for functional tests. So we have scripts that run different things. So very high level test. And then Docker, the demo you've seen is on deepcows.space, but we're moving everything to polarisml.space. So we have a clear domain name. And we'll Dockerize everything, because the challenge is to really have this multi-mission service where we actually show a graph for any mission. So that's a small challenge.
Nice. So that there's a package manager, you could have Betsy there and so on, but don't worry.
Yeah.
I know you just said it. It's not the time to overthink, but rather kick off collaboration, which is actually my next question. Like, literally, how do things move forward? How do, if not requirements, how do user stories or the project, the items that need to be met, the expectations that need to be met, where are they collected? How do those spark off work, and how does that get merged and delivered?
I think the central tool is the GitLab issues. So we put everything on issues. So every time somebody has an idea, we try to save that in an issue. The thing is that we discuss in Riot and in Jitsi sometimes, but mostly in Riot, and information flies away. So we save everything as an issue, and we love to label them. So because we have those three parts in Polaris, with one taking care of fetching data, learning from it, and one for visualization.
Oh, nice.
So it makes things quite clear, but also we play with the labels, like good first bug, for the early contributors, and they want to get in. It's a good, they check the good first bug and they they solve that. I think it's easy. It's easier.
Yeah.
We use milestones also for motivation. So we have mostly about conferences. And then once somebody wants to work on something, there's a branch and an early merge request, which can be marked as a work in progress, so WIP, and so we can continue the discussion and refocus the merge request eventually. And sometimes we just delete the merge request, we create a new one, the branch create a new one once the ideas are clear, and then we continue with threads. We love threads. I think it's maybe it's a part of gamification. We just talked about that earlier today with Tim. I think you want to solve the threads once you open a merge request, and that's the fun part.
Yeah, those are nifty tricks that designers use to encourage people to to close tasks in a fun way, right? In a way.
Yeah. Also, while you have so many things in GitLab, so it's quite. I mean, we can't like keep up and use everything. There are two things that I think we could use. Maybe the design, because we have the website, we want to share some designs, so the design tab would be nice. The packaging, I have to have a look, but we're using PyPy for packages because everything is Python. So I don't know how this makes sense, but definitely the container registry would make sense. Yeah.
Too, yeah. And so once a contributor or anyone in the project decides that the enough feature, enough is enough, or what the merge request was open, and wants to push the code back, you actually encourage code review, right? In a way.
Yeah. So we have like a double approval, so we really need to review everything that is said. Also, we'll use the inline comments, so when we see that something could be improved, it's mostly for improvement. And yeah, that's mostly what we do. And also, we try to keep the merge requests short. So we have one which is like one of the biggest ever. It's still there. You could check it out. But usually it's 1 or 2 weeks merge request, I think, if I'm correct. I hope the guys won't shout on me if I'm not correct.
So then code review passes, thumbs up. I mean, if there's comments, if there's rejections, if there's concerns, that will be inline comments or any other way to provide feedback. But then eventually everything gets thumbs up and it kicks off something, right?
Yeah, so we have every push we have the pipeline anyway, and we are trying to version the product regularly. So at some point we see that we got like, some of the merge requests and already new features like improvement, but then when we have like 2 or 3 new features, I think one of us is like, maybe we should bump the version level. so yeah, in the CI/CD events that are on the screen now, we have this test. As I just said, we want to run batch analysis on many satellites, so it's using the code instead of checking the code. And we're still wondering how. And I think, in the audience, if anyone could help in, finding the right GPU infrastructure. We know the main ones, but maybe we haven't heard about the new stuff and some more dedicated GPUs that works better. That would be cool.
Oh, okay. That's what we need. So you're calling out for help and discovering strong, right, powerful graphic chips for this batch analysis to be run.
Yeah, exactly. That would be nice because we have a computing challenge. So we have a merge request on actually using Dask. We just don't want to use only CUDA derived libraries. We want to be able to parallelize just on CPUs if necessary. Not everybody has GPUs. Yeah.
Okay. So, and you will eventually deploy all of these whenever the pipeline is configured and all this the last stuff we've mentioned to the new website, which will eventually be polarisml.space, right?
Yeah. So the idea is like to see like one box for each satellite that we can track that we're working with. I mean, we'd love to work more with the spacecraft operators. So far, I think we're reaching the point where we're starting to reach out to operators. We used very early the data of the light sail mission. So it's a cool mission. It's a small satellite, but it deployed a huge sail to get pushed by photons from the sun. So it's sun sailing, I would say. Not wind sailing.
Yeah. Sun surfing, right?
I mean, right. Yeah, not bad. That's a good one. And the other one is it's a mission from Guatemala, and it's called Quetzal-1. We didn't have a previous interaction with them. I think one of us made Patrick from the maintainers is on SatNogs and also taking care of the dashboard of onboarding missions, and he knows them from that. But they by themselves, they use Polaris, and they've seen the graph, and they said, okay, it makes sense. And some of the links, we don't know why it's linked, so we need to discuss. So I hope to reach out to them and have this discussion.
So this Guatemalan mission discovered without any promotion of whatsoever Polaris, and they used it. That's fantastic. I mean, that's actually what I guess you all in Polaris want, right? That everyone knows about it and use it freely.
Yeah, that would be nice. I mean, no promotion. I don't think this is really true. I mean, the Libre Space Foundation is already promoting its own channel. Okay. We've been to different events, but you know, you never know where who's listening, who's watching. Yeah. That's a good part.
Well, Red, I have no more questions. I wish the best for the project. The project seems to have like really challenging stuff ahead, but I'm guessing that more people will collaborate and you will be able to overcome those challenges, and it will become more useful for more teams.
Totally open. Yeah. Thank you very much, Jordi. Thank you for the opportunity to be here today and to share what we're doing on Polaris and also with GitLab. And thanks for doing GitLab. Thanks, GitLab.
Thanks a lot. Lisa, back to you.
Yeah, thank you, Red and Jordi, for this very interesting insight in this exciting project. I'll make sure to follow the project along and see where this is heading. And now it is back to our graphic recorder. I would say, let's see what Daniel has created for us. We can see Polaris as the topic at the top. Yeah, it's about spacecraft operations. And we have different satellites I can see in space working together, but autonomous. And that's where autonomous spacecraft operations begins. Also connected in the background because of GitLab. Thank you, Daniel. Looks great. After this creative review, I'm happy to announce our third expert today. He is based in London and will tell us more about version control and collaboration, the kernel of DevOps. Please welcome back on stage, Jordi.
Thanks, Elisa. So yeah, I'm going to cover the topic of version control and collaboration, the kernel of DevOps. I could have called it the foundation of DevOps. That's how I see it. Still, I wanted to make a flashy headline. So that's me. Yes, my name is Jordi Moncompanys. I'm Spanish. I'm based in London, and I'm a senior product marketing manager here at GitLab. My career basically is with developer tools that increase productivity, enable iteration, and basically to move fast and get all the hustle done as best as possible. So the goal of this talk is very simple: is try to convey the idea that version control and collaboration can be achieved through 3 simple examples of the way we do it at GitLab. So let's move on. Basically, let me set the scene. We all know that the demand for good, high quality software systems has been increasing since probably the 90s of the last century, but not only in quantitative terms, but also in qualitative terms. Software is now used to resolve different and more complex problems than ever before, right? That's no news for everyone. But it's not only that, but it's also present in even more devices than ever before. We just saw an example with Red's explanation of where the information comes from. The payloads are hosted. But current interactions with it are now fairly limited to digital touchscreens, CLI, and GUIs. But we can all agree that the mixed reality, voice, and other types of interfaces with software will be very soon the normal to the end user. So we've got a demand in velocity of an ever-growing complex product, such as software systems, right? So that puts a huge burden on software development teams. It is what it is. One that has maybe peaked lately. So in its most concrete form, a software system, which I have decided to beautifully represent with this cute monster, is the sum of all its code, basically. You write the code and you end up with an application that does something useful. There are other artifacts that make sense to the system and enable it to run: data, documentation, etc. And anything you need for the system to be run, literally. This can severely complicate things. The code, however, defines the shape of the other artifacts. And the quality of that code is what gives the modern businesses their competitive edge. The problem for companies is that software development is not a product of a factory system, and will never be actually. Software developers cannot crank out products from a production line. Quite far from it. Software development is a knowledge-based work that can even be done with a distributed team. We just saw a very vivid example of that. So to understand how to build a software system, you need to think about more than just the code and their artifacts. You need to understand how the people on the team work, how the product is structured, and what the goals and structure of the organization are. So we often, or companies often, ignore social issues, such as organizational structures, politics, thinking them secondary to what we perceive to be the main goal, building a software system. While this sounds appealing, focusing on the core goals, these other factors are important to consider. If you don't consider them, actually, they will get in the way when you try to build and deliver systems quickly, which is, after all, the goal that all software engineers have. This is why version control and collaboration is considered at GitLab to be the kernel of software excellency and DevOps. So I'll try to explain through 3 simple examples why we think so, how we put our money where our mouth is by dog fooding and delivering a product globally to enterprises and startups alike with incremental updates on a daily basis. For those of you not familiar with dog fooding, what I'm trying to say is that GitLab is built through GitLab. So all the company builds a product that delivers, and it does so through using GitLab. So the example number 1 of the best practice number 1 would be to go from handoff to handover. Version control sits at the core of what we do. Version control is the backplane on which a software organization communicates work among themselves. This sounds obvious, but some organizations do not really track versions. Even if they have a version control tool, they don't use it. There are plenty out there. They copy files between developers without checking them in, for example. They have no way of identifying what went into a release and how to reproduce a system at one point in time. So GitLab is built upon Git to provide a graphic web-based interface that allows users to benefit from a complete set of features that will enhance source code management and collaboration throughout the organization. It first provides a secure place to store the company's IP. That's the first thing that it achieves. A secure and browsable repository, repo, to collect all requirements and versioned assets used by the teams to deliver value eventually. So what does add value look like? In a nutshell, what DevOps is all about is about shortening the cycle time. One of the ways we do so is by reducing the amount of value delivered. We call it MVC, so minimum viable change. Regardless of how you call it, it will eventually boil down to a high frequency integration model. At GitLab, we use GitLab Flow for that purpose. Again, this is just a proposal. It is a set of best practices that focuses on collaboration and constant delivery of value. At its most basic level, GitLab Flow is all about cooperating, and all starts with a merge request. A merge request, we saw it in Christoph's example, collects a lot of information, namely the information collected from the CI process or the CD process, like we saw in Christoph's example. But a merge request essentially is a branch, yes, but most importantly, it's also a conversation with the team in an orderly manner, with backstops that, thanks to Git's versioning system via commits, allow us to roll back, and a conversation with different permission levels that range from guests who can see a project, the guests who can only see a project and have no other level of permissions, but to admins and owners with all the privileges associated to them to manage the project and manage the users, the different roles. So not everyone is allowed to do everything to the IP hosted in the repo. It is also a merge request, again, remember, a branch, but also a conversation with the appropriate stakeholders that may need to review changes to code their team owns. I am thinking of, for example, security features or anything that affects LDAP or Active Directory. If the new feature proposed in the MR relies upon them or suggests changes to be done, you might as well let the code owners, in this case, that's the name of the feature in GitLab, that these changes are proposed, right? We're talking about allowing the fundamental modules and the most secure modules, the modules that require more security in your code base, to have owners that are advised or let known about changes to be done to their components. Again, a merge request, what triggers is a fully structured conversation and cooperation between the relevant stakeholders. A conversation that is absolutely contextual to the code and the functionality discussed. Since we have reduced the amount of code and functionality and eventually value that we are delivering, as we saw in the small batching process, we can pinpoint feedback requests such as code reviews to the code line level. We can go really in depth and really into detail. A merge request in GitLab therefore combines the best amount of stakeholder notification, permission-based functionality, and process automation. A balance between where developers need to devote their attention and their brain cycles, and automated processes that get all the hassle done. So handing over small batches of code between team members instead of handing them off will give the ability to provide accurate and fast feedback and reviews. Submit those changes for approval and permission-based with permission-based rules, for example, and increase the frequency of integration while keeping quality at the required standards. So high frequency with enough quality. The next example is about another of GitLab's mottos, which is everyone can contribute and should contribute, I would add. So this quote from our countersign doubles down in the concept of shortening the cycle time that I mentioned before. But it's actually a little bit flawed in a way, because this won't work for functionally based staff companies. So companies that divide their staff into functions. Because in that case, teams will optimize to a maximum, yes, like this quote states, but to a local maximum. Functional organizations encourage local optimization. Each group is focused on doing its part instead of ensuring that the overarching goals are met. So traditional staffing and organization models are a poor fit for small batch processes, the ones that we just described in the previous example. Most organizations are grouped into functional silos. Developers are in one bucket, project managers are in another, etc. The same goes for Q&A, security, database administrators, architects, and so on. So the small batch approach, however, moves too fast for this type of organization. Communication and handoffs, that's where handoffs happen, between each silo takes time. Business analysts must communicate and explain requirements to the developers. Developers need to document features for Q&A, and the list goes on, throwing stuff over the fence, basically. That is why companies such as these, the ones in the slide that you can see, are shifting their designer to developer ratio by hiring more designers and incorporating them to the software delivery. You can see there IBM, which is a surprisingly a good example, but ourselves, we have done it. We are incorporating designers more and more to the basic unit of software engineering and development. So basically the key element, the key idea here is that different profiles working with different assets and different workflows can actually excel at communicating with each other. First, getting rid of handoffs and starting to work on a handover basis. By doing fast handovers and testing the result in the same conversation where in the same conversation where the features are discussed, communication becomes easier and contextual. So for example, we are making this at GitLab, we are making designers become first-class citizens, just like developers are currently at GitLab. This particularly is being taken care by the design management capabilities of GitLab, which aim to simplify the workflow for designers and bring them into the DevOps process as first-class citizens. So design management is about giving designers the ability to engage with the relevant stakeholders and the creators of the code that will make the designs part of the end user software. This comes with all the benefits of contextual, laser-focused conversations and review processes that we saw before in the code review features that were shown in the first example. So just as we saw before with the source code management features, designers are able to version their assets. They will be able to upload their assets to GitLab and have different versions of them that are archived and a single source of truth for the current version. They can engage in threaded, resolvable discussions that will make iteration and handover fast enough and meaningful as part of the design review, and all in the same place. Just like Red was mentioning for the Polaris project, they aim to use this eventually. This is happening at the issue level. So again, this is a core value for GitLab. We're doing it. We're putting that into the tool, and it is also applicable to data teams. Red mentioned it. Jupyter notebooks are available in GitLab, but also to infra teams with GitOps and so on. So at GitLab, basically, we believe that everyone should contribute and that cross-functional teams respond better and faster if the assets and the workflows that they need are supported and enhanced in the same platform. And finally, the last example would be that given the premises that we have just explained in the previous two examples, so small batching, small batch thinking, cross-functional teams being supported, having their assets supported, their workflow supported and enhanced, and so on. What needs for everyone to contribute is to foster trust. So it's not enough with providing the framework and the functionality to get everyone on board, right? With Git's versioning system or with all the features that we've gone through. But we actually want team members and the relevant stakeholders to keep the code safe and create new features fast. So it is also about creating a trust culture that makes all this shine. The processes, policies, technical documents, they all have to be properly documented and fully accessible. Everyone should have access to every part of them. That's why we publish at GitLab, the way we operate, the way the company is managed, the way the product is built, and so many other things at GitLab, because we're an open core company. We publish that in the shape of a handbook that is completely available, freely available for everyone. And it is for us as company employees, browsable and searchable in any search engine that we know. So as an increasingly remote context, like the one we're currently living, but also as like the future looks like a little bit, building trust is done by having all the processes documented so that everyone can collaborate at any time. For that to happen, we have at GitLab, we provide the web IDE, among other things. But we saw a deep dive in Christoph's demo about how to use the GitLab web IDE to manage runners and so on. In this case, you will have in the same interface, in the same platform, a web IDE hosted there, right there, so that every process that has been established in the company, in the project, wherever, after a workflow of issues and merge requests and issues and merge requests, after adding value to the product itself, it is contextually based and it's also web hosted. So right there, you can look for any files and commit changes in the same browser window that you have done all the previous activities that I mentioned. So a developer can create, for example, a version code snippet for anyone to reuse and store it in the same project, because the process has demonstrated that this code snippet, X code snippet, will be used for other purposes in the future. But he or she can decide to produce a big piece of documentation. So again, this can be achieved immediately just by opening the web IDE. These are, I won't go into much depth because Christoph's demo went into the full power of the web IDE, which by the way can be seen in two different visualizations, in dark mode and light mode. And again, to build trust, the last element, the fundamental element for it to be built is that documentation should occur first in a structured and organized way before being disseminated, right? Before being even promoted. So it has to be built into the workflow of the user, and therefore GitLab is providing enough capabilities for that to happen in the most seamless way possible. The end goal for us and for the users of GitLab is to create a culture of documenting and participating. Once you want to participate, you will find enough resources to know how to do it, and to proceed. Because small, minimal viable changes will eventually add up to a process or a full feature that will require to be documented and consumed by the end user. For that to happen seamlessly, GitLab provides easy ways of doing so, such as GitLab pages, wikis, and static site editing capabilities. So basically, that's all I had to say. Those are 3 examples on how we foster collaboration at GitLab. We deliver value very fast. And well, back to you, Lisa. I'm looking forward to the questions.
Thank you, Jordi, for this great explanation about version control and collaboration. I will surely be able to work better together with our developers. For all viewers, this is not yet the end. We will quickly watch what our graphic recorder has created, after which we'll announce the winner of our quiz. So let's see what Daniel has created right now. Okay, we can see GitLab and we can see the topic in the middle again, version control and collaboration, the kernel of DevOps. And it's not just a topic, it's a loop, because DevOps is a never-ending development. And on the right side, I've seen the software illustrated as a robot, which contains many little robots, because GitLab helps to develop the small robots to influence the big one and to adapt to, for example, on the left side, the all-time changing world. In the bottom, we can also see some companies which are using GitLab already. And we know why, because it has a lot of advantages like iteration, visibility, velocity, and so on. Great, again, thanks to our graphic recorder for great scribbles. We will share all graphics with you by mail after the event. And now it is time for a small quiz. Here are the questions. Question number 1. How many languages and frameworks does GitLab SAST support? 4, 10, 18, or all? It's your turn. And the most TypeScript, C++, or Python? So let's see what you did with question number 2. Some of you voted for C++, for Python, but most of you for Ruby, which is the correct answer. Number 3. GitLab has recently gained an industry standard around security compliance. What was it? ISO IEC 27001, SOC3, SOC2, or PCI DSS version 321? So hard to read the question. Let's see how hard it is to answer. So, and the correct answer is SOC2. Question number 4. What GitLab feature enables distributed teams to fetch repositories in seconds, no matter where they are based? GitLab CI, GitLab Geo, Auto DevOps, or Google Cloud? So let's see what the most of you voted for. Some of you for Auto DevOps, but the correct answer is number B. And the most of you are right as well. Number 5, how many GitLab runner executor types are currently in place? 7, 8, 9, or 10? It's your turn again for the last question. Let's see what you are voting for. It's very close between 7 and 8. Okay, many votes for 9 as well, but the correct answer is number 8. Thank you for joining me here. Let me check with the studio if we have a winner. Give me some seconds. And yes, great news, ladies and gentlemen, we do have a winner, and his name is Mr. Stijn van Bos from the National Bank of Belgium. Congratulations. So after all this information we learned today, it is now time for our live Q&A session. If you have any questions, feel free to type it in the chat. Our experts will answer them live, and we already have our questions. So experts, get ready. And I would say the question, Christoph, you should answer it, because the question is, how can we bring third-party tools into the GitLab pipelines?
That's a great question. I think there's a difference between the out-of-the-box integrations that are already there, like issue track, Bugzilla, communications channels, etc. And next to that, you can always build your own integration by using the APIs that are available. And in general, if you can run a CLI script in Shell, or the technology supports a Docker container, you can always use that to integrate it as well.
Okay, thank you, Christoph. Then I have a question for Red. Red, you mentioned that you have double approvals for MRS in GitLab. How do you control this approval process?
I think we have options to put a number of approvers. We did that some time ago. And the challenge is actually to get the approvals as quick as possible, so the MR is not open for too long. So as a team of 4 maintainers, it's quite hard sometimes. You know, we're all busy. This is a spare time project which has grown big, so we get some many demands. But I think we just remind each other, and that's how we do it. So we go through the chat as well. So I hope I answered the question.
Hope so too. Thank you. And Christoph again. Christoph, you used Kubernetes in your demo. Is it Kubernetes a requirement of GitLab CD?
It's not a requirement. We have a very tight integration that exists to make it easier to manage and to use Kubernetes and to deploy to Kubernetes as well. However, basically each technology can be supported again by running a shell script or custom script wherever you want. So if you want to deploy to a cloud-based system, you can do that. A local system, you can do that in basically any technology that supports well, deployments by command line or by one of the integrations, like for instance Docker containers.
Okay, thank you. And last but not least, Jordi. Jordi, you mentioned that GitLab follows an operating handbook. Is this publicly available and always up to date?
Yeah, well, it should be up to date. It is a value that at GitLab, we are an open core company, and therefore we are fully transparent in how we operate. But it is a challenge, as I explained in my presentation, to document every single thing you do. It's not easy. So that's why we're trying to make it as easy as possible. But yes, the handbook, it's 3,000 pages long. Everyone can contribute, even people from outside the company, if they are aware of what the process is that they are documenting is about. But yeah, we're constantly just reading Twitter this morning. I saw that a colleague, Michael Friedrich, saw a problem with I can't remember right now, but detected a problem in the review app, found the solution, and immediately documented the problem. So literally with the solution, he deployed a page to the handbook or an explanation to an already existing page of how these things are achieved, like immediately.
Okay, thank you. Thanks to our experts for answering the questions, and thank you for all the questions you've sent. The ones we could not answer during the show will be followed up by email. So then we are already at the end of our show. I hope you all had a good time and learned more about GitLab and the possibilities. You will all receive the presentations in our follow-up email. Also, there will be a quick feedback survey with another chance on a great prize. Thanks to all our speakers, and a special thanks to our guest speaker, Red. I'm sure to see more of you in the future. Thank you all for joining today. Have a lovely week, and I hope to see you next time live or another virtual opportunity. Goodbye.